In this set of videos, we're going to be covering static fluids, which is fluids that aren't moving or not moving very much at all. Um, and so the number of topics we're going to cover, the topics we'll cover during this set of videos: density, pressure, buoyancy, Pascal's principle, hydraulics, which you guys need to know a little bit about, Archimedes' principle. All of these are really have to do with static fluids. And when I say hydraulics, is when you're going to be like, but they move. Well, yes, they do, but they're not really, it's not the properties of their motion that are important in hydraulics. It's much more static than when we get to dynamic fluids, which will be the next section or the next set of videos. And when we talk about a fluid, what are the properties of a fluid? Well, atoms free to move about in a fluid. And so they they can have some intermolecular attraction to each other, but they're not stuck together in the way that the atoms in, say, your pencil are stuck together, right? And so fluids, the atoms in fluids are free to move around. Now, that doesn't mean they go floating all over the place necessarily, because here's a fluid, it's canola oil, and the canola oil is simply filling the container it's in and takes the shape of the container because gravity pulls it down into the container because canola oil is denser than air. Over here is a container that's also filled with a fluid, but it's filled with air, and so you don't really think about it. And you don't even see the fluid inside of it because it doesn't affect the optical properties, something we'll cover later. And if you notice carefully here, inside of this beaker filled with canola oil, there is another beaker filled with canola oil. And the only thing you can see from that other beaker is the writing on the beaker. Um, and there are other things here that optically going on that are interesting with canola oil and Pyrex because they have the same index of refraction. For instance, you can see the inner edge of the beaker filled with air, but you cannot see the inner edge of the beaker filled with canola oil. Anyway, so here are these two fluids filling these beakers. If this were liquid helium super cool or super cool. Oh, that's kind of funny. Okay, liquid helium is super cool because it will actually flow up and out of a container because liquid helium kind of wants to be one layer thick. All right, that's it for our introduction to this section, and we'll continue with the next video.